All right, in this video, we're going to talk about section 3.3 dealing with subtraction of whole numbers. And in this video, we'll look at various models related to the meaning of subtraction. We'll recognize the inverse relationship between addition and subtraction. Also, we'll use subtraction algorithms, which does include the standard subtraction algorithm. And then we'll use mental subtraction computational skills and estimation techniques. All right, so let's start off with some subtraction models here. Subtraction of whole numbers can be modeled in several different ways. One of them, of course, is the takeaway model. And this views subtraction as a second set of objects being taken away from the original set. Okay, so in this case here, we have a circle with 8 blocks altogether. And let's say we want to take away 3 blocks. So here, 3 blocks are circled, and we want to take those 3 blocks out. When that happens, we're going to be left with 5 blocks. So that's the representation of 8 minus 3 equals to 5. Or in this case, 5 blocks left. All right, the second model is the number line model. The subtraction is represented by moving left on the number line a given number of units. So to represent 5 minus 3, we start at 0, go all the way to the right 5. But we're going to go to the left 3 because we're subtracting 3. So we go to the left 3 places, which means we'll end up at 2. So that represents 5 minus 3 equals to 2. And then the third is the missing addend model. That's an algebraic type of reasoning which is used where students compute a difference by determining the value of an unknown addend. And usually in earlier grades, they use the box to represent the unknown. In algebra, they use a variable like x. So for this one, 8 minus 3 is equal to how many? That would be that box. You just fill in the box with the missing answer. So here, 8 minus 3 would be 5. Yeah. Now this can be thought of as the number of blocks must be added in order to get 8. So here, the number 8 minus 3 is the missing addend in the equation. 3 plus what number will give you 8? And in this case, it will have to be 5. Okay, so in this example that I'm going to show you here, let's say we want to write a related addition sentence. We're going to write a related addition sentence. Like in this case here, 10 minus x, which is the unknown, that would be equal to 2. So here we need to find what x is so that 2 plus the number, which we're looking for, that's x, equals to 10. So this is a related addition sentence for 10 minus x is equal to 2. All right, now we'll look at the definition of subtraction of whole numbers. If we have any whole numbers a and b such that a is greater than or equal to b, then that means that a minus b is a unique whole number called c such that b plus that number c must be equal to a. So like with that 8 minus 3 that we got through talking about here at the top, that's going to be 3 plus what number will give me 8. Okay, so I'm be looking for that unique whole number that will make that sentence true. All right, now we have the comparison model. when we subtract whole numbers. In this case here, let's say 1 has 8 blocks and Susan has 3 blocks. How many more blocks does 1 have than Susan? Okay, so we can illustrate that by comparing how many more blocks 1 has than Susan. And in this case, the difference there is going to be 5. Okay, so in other words, 1 has 5 more blocks than Susan. So that's how we do that problem, 8 minus 3, which will give us 5. All right, now for properties of subtraction. It can be shown that if A is less than B, then A minus B is not meaningful in the set of whole numbers. Therefore, subtraction is not closed on the set of whole numbers. Okay. Example of that would be something like 5 minus 8. Here 5 is less than 8, so this would not be meaningful for the set of whole numbers. Now, later on, we will be talking about integers in future videos here. Okay, so here subtraction would not be closed on the set of whole numbers. Okay, and also subtraction would not be commutative. So 8 minus 5 is not going to give you the same answer as 5 minus 8. So do keep that in mind. All right. Let's talk about introductory algebra using whole number addition and subtraction. Sentences such as 9 plus 5 is equal to the unknown, and they're using the sun to represent the unknown, and 12 minus, and here they're using a diamond for the unknown, equal to 4 can be true or false, depending upon the values of these unknowns. For example, if, let's say, the sun equals 10, then 9 plus 5 equals to that sun, which is 10, it's going to be false. If the diamond is equal to 8, then 12 minus that diamond, since the diamond is represented by the number 8, 12 minus 8 would be 4. That would be true. So here, if the value that is used makes the equation true, that means it is a solution to the equation. Okay. All right, now let's look at some algorithms for subtraction. As with algorithms, we can use base 10 blocks to provide a concrete model for subtraction, as you will see on the next page. Okay, so for a problem like 243 minus 61, we first represent 243 with 2 flats, 4 longs, and 3 units, as you see here. 2 flats here, and then you got 4 longs and 3 unit pieces for 243. Now to subtract 61 from 243, and by the way, I didn't write the subtraction problem here, but this is 243 minus 61. Now to subtract 61 from the 243, we're going to try to remove 6 longs and 1 unit from 243. And here we can remove 1 unit. So here, one of the unit pieces X'd out. So 243 minus 1, that's 242. But to remove 6 longs, we're going to have to trade one of the flats for 10 longs. Because 10 longs does equal to a flat, we can trade out one of the flats in exchange for 10 longs. And now we can remove the 6 longs here. Okay. So if I remove these 6 longs here, so here we can remove those 6 longs. Once those are removed, we'll be left with 8 longs, along with the 1 flat and the 2 units. So here, this represents a number 182. So 243 minus 61 would be 182. Okay. All right. Now let's look at this example here. This might not have anything to do with subtraction, but it might be dealing with a comparison. At a volleyball game, the players stood in a row ordered by height. If Lyle is shorter than Joan, Mona is taller than Joan, and Shayna is taller than Mona, who is the tallest and who's the shortest? Okay, so Lyle is shorter than Joan. So if I want to order this, I'll put Lyle down here at the bottom. And I'm ordering this from tallest to shortest, by the way. And Joan had to be above Lyle. Mona is taller than Joan. So Mona will be up here, and Shayna is taller than Mona. So she'll be above Mona. So that means Shayna is the tallest and Lyle is the shortest. So here we're just ordering this from the tallest to the shortest and identifying who's the tallest and who's the shortest. All right, example 3 in the homework. Tom's diet allows only 1,800 calories per day. For breakfast, Tom had skim milk, which is 90 calories, a waffle with no syrup, 120 calories, and a banana, 119 calories. For lunch, he had half a cup of salad, 185 calories with mayonnaise, 110 calories, and tea, 0 calories. Then he had pecan pie, which is 570 calories. And I did forget to add this part right here. This is the actual question. Can he have dinner consisting of a steak that's 250 calories, half a cup of salad without mayonnaise, and tea? And he's allowed only 1,800 calories per day. All right, so now let's look at what he has already had. Skim milk, which is 90 calories, plus a waffle with no syrup, 120 calories, and a banana that's 119 calories. Then for lunch, he had a half a cup of salad, that's 185 calories. And then mayonnaise, with mayonnaise, 110 calories. Tea has no calories. And then he had a pecan pie, 570 calories. So in this case here, if we were to add these numbers together, it'll be 90 plus 120 plus 119 plus 185 plus 110 plus 0 plus 570. So far he has had 1,194 calories. Now he's only allowed 1,800 calories here. So if I take 1,800 minus 1,194, this will be 606. So he's allowed 606 calories that he can intake. Now, here's the question. Can he have dinner consisting of steak, which is 250 calories, half a cup of salad without mayonnaise, and tea? Let's see, the steak is 250 calories. The half a cup of salad is 185 calories. Excuse me. 250 calories for the steak, and then minus 185 calories. So that means if I take away 250 calories for the steak, and 100, excuse me again, 185 calories. This will be 171 calories that he has left to intake. So in this case, he can, to answer this question, he can have the dinner consisting of a steak and a half a cup of salad without the mayonnaise and the tea. Okay. All right. All right, next we'll look at the equal additions algorithm. And in the equal additions algorithm for subtraction, that's going to be based on the fact that the difference between two numbers does not change if we add the same number to both numbers. So like 255 minus 163. And sometimes the equal additions algorithm is used so that you're able to subtract user-friendly numbers without doing any regrouping. So like the 163, if I want to make that 170, I'm going to add 7 to the 163, and I'm also going to add 7 to the 255. So I'll end up with 262 minus 170. Well, let's say I want to make that 200. All right, in this case here, 170 is 30 away from 200, so let's add 30 to the 170, and I'll also have to add 30 to the 262. So 262 plus 30 will be 292, and 170 plus 30 will be 200. Now I can easily subtract 200 from 292 to get 92. That's the final answer. Okay. All right, now take a look at this example using the equal additions approach to compute each of the following. So in part A, I got 84 minus 39. Okay, now I'm going to do something with this 39 here. 39 is 1 away from 40, so let's do this. Add 1 to the 39. But if I add 1 to that 39, I need to add 1 to the 84. So 84 plus 1 will be 85 minus add 1 to the 39, that will be 40. So I can easily subtract 40 from 85, which will be 45. So that's what 84 minus 39 will be equal to 45. And then part B, let's say we got 635 minus 76. And I want to use the equal additions approach for this. Okay. 76, I'll make that a number with as a multiple of 10. I'm gonna use 80. 80 is 4 away from 76. So if I add 4 to the 76, I'll also add 4 to the 635. So let's add 635 and 4 together, you'll get 639 minus 4 plus 76 will be 80. And you know something else? Let's make that 80 100. That way I won't have to do a little bit of regrouping. 80 is 20 away from 100, so I'm going to add 20 to that 80. And if I add 20 to the 80, I must add 20 to the 639. And 639 to the 20, that will be 659 minus 80 plus 20 is 100. Now I can easily subtract 100 from 659. That would give me 559. So 635 minus 76 will end up being 559. Okay. All right, next is the counting up algorithm. Counting up. Now this algorithm can be best described as the making change method. It is the way that cashiers and tellers give change for purchases. Today, with calculators and computerized cash registers, it has become sort of a lost art. However, It is a way to do subtraction in your head. It uses the idea of the missing add-in model for subtraction. Students are encouraged to count up to nice numbers, which are multiples of 10, 100, 1,000, etc. Like, for example, if we want to subtract 100 minus 31 using the counting up algorithm for subtraction, is what we do. We take the 31. Well, 31, we're going to add something to get a multiple of 10. Let's add 9 to the 31. That will be 40. And then 40 is 60 away from 100. Let's add 40. Let's add 60 to the 40. That would give us 100. Now, these two numbers in this box, add those two, 60 and 9 together will give you 69. So that means 100 minus 31 would be 69. So let's try to use that counting up algorithm with these examples, like 91 minus 27. All right, now let's start off with that 27. Let's make 27 a number with a multiple of 10. Well, 30 is a multiple of 10 and is 3 away from 27. So if I add 3 to the 27, that would give us 30. And I'm trying to reach 91. Well, let's try to make that 30 90 by adding 60 to the 30. That would give us 90, and 90 is 1 away from 91. So add 1 to that and you'll get 91. Now, it's these numbers right here is what I'm going to add. That's going to represent the final answer to 91 minus 27, which is in this case, 3 plus 60 is 63 plus 1 more would be 64. So 91 minus 27 would be 64. All right, part B, 63 minus 46. All right, we're going to start with this number 46 and try to work our way up to 63. Let's see, 46 is 4 away from 50. So if I add 4 to the 46, I'll get 50. I'm still trying to get to 63. Let's see here. 60 is 10 away from 50, so add 10 to that 50, you'll get 60. And then to get to 63, I'm 3 away from that, so I'll add 3 to that 60 to get 63. So now I'm going to add these numbers here, the 4, the 10, and the 3. Well, 10 plus 4 is 14. 14 plus 3 is 17. So 63 minus 46 equals 17. All right, now let's look at this example using that counting up algorithm. This one is similar to that. Noah owed $11 for his groceries. He used a $50 bill to pay. While handing Noah the change, the cashier said 11, 12, 13, 14, 15, 20, 30, and 50. How much change did Noah receive? And here's what the cashier said. Okay. And that's the amount of money that Noah received. Since he owed $11, that would mean he received $0. And then when the cashier said 12, he received $1. For 13, he received another $1. 14, he received another $1. 15, he received another $1. For 20, you receive $5, $30, $10, $50, $20. So we add across 1 plus 1 plus 1 plus 1 plus 5 plus 10 plus 20. He received $39, which is his change that he received after paying $11 of gross for his groceries using a $50 bill. All right, next is the trades first algorithm. The trades first algorithm. All right, this algorithm is very similar to the standard algorithm, except that all regrouping is done before any subtraction is carried out. Using base 10 blocks may help with students' understanding of how to subtract. So like in this example, let's say we wanted to use the trades first algorithm to subtract 122 minus 37. And this is illustrated on the next page. Here it is, 122 minus 37. We begin by representing 122 with base 10 blocks. So here, 122 is represented by 1 flat, 2 longs, and 2 units. Now, in this case, we need to take away 7 units, but we only got like 2 units. So this is where we trade one of the longs for 10 units. So that means we'll have a total of 12 unit pieces. Okay, and now we need to take away 3 longs, but you only got 1 long left after you trade it. So now we're going to take that 1 flat and exchange it for 10 longs, because 10 longs make up a flat. So we trade the 1 flat for 10 longs here. And now, after all the trading is done, we can subtract the numbers in each column. So that means we can subtract 7 units and subtract 3 longs. You'll be left with 8 flats and 8 longs and 5 units for the total of 85. So 122 minus 37 will give us 85. Now this next illustration shows place value for 122 minus 37. 1 for the hundreds place, 2 for the tens, and 2 for the ones. That's how we write 122. Now here we're going to trade one of the hundreds for 10 tens, as you can see. There's 100 makes up 10, 10 will be exchanged for 10 tens. So we add the 10 to the 2 to get 12. And then we trade one of the ones for 10 ones. So we add the 10 to the 2 we already have to get 12 after trading it off. And then when we subtract, we write the 37 in the correct columns. 3 will be in the tens place, 7 will be in the ones place, and then we subtract. 7 from 12 will be 5, 3 from 11 will be 8. So the final answer there will be 85. All right, now in this homework example, we're going to compute 458 minus 64 using trades first algorithm. So we first do the trades and then we subtract. And I'm going to do it this way because the base 10 blocks will be too much for using these bigger numbers. So I'm going to begin by writing this 458. The 4 is in the hundreds place, the 5 is in the tens place, and 8 is in the ones place. Now, in this case here, if I was to write it vertically like this, I can subtract 4 from 8. So I don't need to do any trading. But in this case, I need to do this. I can't subtract 6 from 5. So let's look at this here. We're going to trade one of the hundreds. Okay, so I'm going to trade one of the hundreds. And I have 3 left over. That 100 that I traded will convert to 10 tens. So I add 10 to this 5 to get 15. Now bring down the 8 here. And I'm going to go ahead and subtract, bring down the 64 because I'm going to subtract 64 from this. Now, if I do 4 from 8, that will be 4. 6 from 15 will actually be 9. Now we'll bring down the 3. So I'm left with 394. So that means 458 minus 64 would end up being 394 using that trades first algorithm. Okay. All right. Now this is also useful in this example right here. Let's say we've got 5 hours, 33 minutes, and 38 seconds, minus 3 hours, 50 minutes, 56 seconds. And here I want to subtract. Sometimes that trades first algorithm would work here. Now, I do need to mention, if you already don't know, that 1 hour is going to be 60 minutes. And also 1 minute is 60 seconds. Okay. Very important. All right, so here I can't subtract 56 from 38. So I need to do a little regrouping by trading one of the minutes in 33 minutes, which would be 32 minutes. Now, of course, 1 minute is 60 seconds. So that 1 minute that I'm trading converts to 60 seconds. I'll add the 60 seconds to the 38 seconds. This will be 98 seconds. Now, if I subtract 56 from 98, that will be 42. So it'll be 42 seconds. Now, unfortunately, I'm not going to be able to subtract 50 minutes from 32 minutes. So now we have to trade one of the hours. In 5 hours, I'll be left with 4 hours. Now, of course, 1 hour converts to 60 minutes. So I add this 60 minutes to the 32 minutes I've already have. That'd be 92 minutes. And now I can subtract 50 minutes from 92 minutes. That will be 42 minutes. And then 3 from 4 will be 1. So my final answer there will be 1 hour, 42 minutes, 42 seconds. All right, now let's look at some mental math techniques that are used in subtraction. One of them is breaking up and bridging, just like in addition. So if I did 74 minus 26, I start off with doing 74 and then break the 26 up as 20 and 6 and subtract each one. So 74 minus 20 would be 54. And then 54 minus the 6 will be 48. So 74 minus 26 would be 48. Number 2 is the trading off approach. Same problem, 74 minus 26. Now, if I add 4 to 74 and 4 to 26, because in this case, I want to make that the number that I'm subtracting from a multiple of 10 in this case. 74 plus 4 would be 78, and 26 plus 4 would be 30. And I can easily subtract 30 from 78 to get 48. And the drop the zeros approach would definitely be easy. So 7,400 minus 600, if I drop the zeros, I'll just have 74 minus 6. 74 minus 6 will be 68. So 7,400 minus 600 will have to be 6,800. So sometimes it does help to use these type of mental math approaches to come up with your final answer when you subtract. Okay, let's take a look at this homework example. Let's say I want to compute each of these mentally, like 190 plus 98 minus 25 plus 10 plus minus 110 plus 27. Let's see what I can do with this one. If I was to do this mentally, I can do this, add 190 and 10 together. Because I know 190 and 10 would give me an easy number to work with. That would be 200. What else can I do here? I have 200 plus 98 minus 25 minus 110 plus 27. Well, if I do 200 minus 25, that will, of course, give me 75. That's easy to work with. So that would be 75 plus 98 minus 110 plus 27. I guess if I do 98 plus 27, that would be 125. So 75 plus 125 minus 110. And then 75 plus 125, that's 200 minus 110 would end up being 90. So sometimes using the mental mathematics approach, that final answer I see why I messed up. 200 minus 25 is 175. So actually, this will be 300. And 300 minus 110 will give me 190. Okay. So that should be 190. Okay, because 200 minus 25 is just 175. All right, now part B. Let's say we got 89 minus 44 plus 50 minus 39 plus 44. And I want to compute those mentally. I'm going to group this 80 minus 39 because I can easily subtract that because 9 minus 9 would be 0 and then 8 minus 3 will be 5. So that will end up being 50. So I have 50. Now I'm going to do this, bring down the plus 50 here, and then I'm going to bring down the plus 44 and then minus 44. Because notice I can add 50 and 50 together, that's 100. 44 minus 44 is 0. And 0 plus 100 is 100. Okay. So this is how you can compute problems like this using mental mathematics. Okay. Here's another example. Now here they want you to describe an approach that is valid. Describe an approach that is valid, like 650 plus 52 plus 350 in part A. Okay. One approach is to use compatible numbers like 650 and 350. Because if I add 650 and 350, that's going to equal 1,000. So this will be 1,000, and then add the 52 to give you 1,052. So that approach, you have to use compatible numbers like 650 and 350. Now for part B, you got 584 minus 85. All right. Now notice in this case that the 85 is one more than 84. So if I do this, 584 minus 84, break that 84 up as, 85 up as 84 and 1. 584 minus 84, that's 500. And then I still got one more to subtract. So 500 minus 1 would be 499. Okay. So one less than 500 would be 499. And that would be the final answer there. So we can break 85 up as 84 and 1, and then subtract 84 from 584, whatever that is, which is 500, subtract 1 from that to get 499. Okay, that's part B. Now part C, we got 240 plus 80 plus 60 plus 43 plus 7. With this technique, well, with this problem, we can deal with the compatible numbers like 240 and 60, and another pair of compatible numbers, 43 and 7. Add those two. 240 and 60, of course, will be 300. 43 and 7 is 50. So that means I will have 300 plus 80 plus 50. $300 plus 80, of course, is 380 plus the 50 will be 430. Okay. So this is how we can use mental mathematics to add and subtract whole numbers. All right, now using the breaking and bridging approach, we want to compute 465 minus 53 mentally. Bring over the 465, break 53 up as 50 and 3 and subtract each part, like 465 minus 50. That would be 415, 415. And then 415 minus the 3 would be 412. So in this case here, 465 minus 53 will end up being 412. And this one, here we're going to come up with an approach that's valid and then compute these mentally, like 402 minus 94. And with this one, I would try to make 94 a multiple of 10. And 100 is 6 away from 94. So I would add 6 to the 94 and add 6 to the 402. That's using that trading off approach. So 402 plus 6 will be 408, minus 94 plus 6 will be 100. And I can easily subtract 100 from 408 to get 308. So here I added a value to 94 to make it equal to 100. Okay, and add the same to the 402. So I added 6 to the 94 and added 6 to the 402. Okay. Part B, 50 minus 20 plus 250 minus 50. Let's add the compatible numbers together, like 50 and 250. That's 300. And then we got minus 20 and a minus 50. Well, if I do 300 minus 20, that would be 280, and then subtract 50 more from the 280, that would end up being 230. So the final answer there will be 230. Okay. And finally, let's say we had this. Suppose you had a balance of $2,489 in your checking account and wrote checks for $97, $212, $413, and $530. Estimate the four check amounts and the beginning balance to the nearest hundred to estimate the new balance. All right, let's start up with and we're going to round each one of these to the nearest hundred, like starting with the $2,489. That's the beginning balance. Let's look at the digit in the hundreds place. That will be the 4. To the right of that is 8. 8 is bigger than 5, so we increase that 4 to a 5. So be 25, and then change the other digits behind the number that we're rounding off to zeros. So $2,489 will round up to $2,500. And now we have 4 checks. One for $97, one for $212, one for $413, and one for $530. We're going to round each one of these to the nearest hundred. Well, $97 is close to $100, so we'll round that off to $100. The one is less than 5, so the 2 remains the same. That's $200. 413 is the 4, 1 is less than 5, so the 4 remains the same. And 530, the 5, then 3 is less than 5, so we round that off to $500. And let's add these together. This will be 100 plus 200 is 300, plus 400 is 700, plus 500 will be $1,200. Okay, we began with $2,500. Approximately, subtract approximately $1,200 from that, and you will get $1,300. So here, the estimate of our new balance is $1,300. All right, so that does conclude this video on section 3.3 dealing with subtraction of whole numbers. Feel free to email me if you have any questions about any of the problems that are presented in this video or problems that are in the homework for my math lab.